घूम रहा था कितना बढ़िया। हाँ, अरे मोहन। हाँ, और बिल्कुल वही रखा जैसे तब था वो जब हम छोटे थे।
नमस्कार सर.
नमस्कार नमस्कार. How? So people have
ଜଏନ୍
joined.
ହଁ ହଉଛନ୍ତି. अनिल.
This is your new campus, Sasanka?
करना पड़ता है.
अरे तुम्हें क्या
Extra ready. Good morning, everyone. Today's first session is from 10 to 11:30, and second session will be from 3 to 4:30. Today's first session, the resource person is Dr. Ranjan Patra from the Berhampur University. He is a professor and HOD of Department of Computer Science, Berhampur University. A brief profile of the Dr. Patra sir. Now he got his PhD in Computer Science from Central University, Hyderabad, and now he is a professor and head of the Department of Computer Science, Berhampur University. He has been teaching computer science for the last 32 years. He was a United Nations Fellow at the International Institute of Software Technology, United Nations University, Macau. His research interests include artificial intelligence, cloud computing, data mining, and e-governance. He has successfully guided 14 PhD students and more than 100 master theses. To his credit, he has about 150 plus research publications in reputed journals and conferences. He has extensively traveled to many countries in USA, Europe, Australia, Africa, and Southeast Asia for presenting research papers, chairing technical sessions, delivering invited talks, and for participating in panel discussions. He has been a member of editorial boards and program committee of many international journals and conferences. He is a member of ACM and a life member of CSI India and IST. So before going to topic, his topic is intelligent agent. What is the intelligent agent? Just I am giving one concept, then the session will be started. In artificial intelligence, an intelligent agent refers to an autonomous entity which acts directing its activity towards achieving goals. It is an agent upon an environment using observation through sensors and consequent actuators. So here goal is your agent and the actuator is the using the intelligence. For example, you are using the AI assistants like Alexa and Siri. They are the example of the intelligent agents. They use sensors to perceive a request made by the user and they automatically collect data from the internet without the user's help. They can be used to gather information about its perceived environment such as weather and time. So there are so many intelligent agents are available everywhere you are using. In software also there is a agent. So sir will discuss the details about the what are the intelligent agent and what are the research activities available in the intelligent agents. I handed this session to Dr. Manas Ranjan Patra sir. Welcome, sir.
Yeah, good morning to all of you. Thank you so much, Dr. Gantayat and faculty members of GMRIT. So I am now, today I'm associated with GMRIT after a long time. I remember I visited GMRIT a few years back in different context. Today I'm very happy that again I'm part of this faculty development program. I can see there are about 40 plus participants for this FDP.
Some are in YouTube also.
Some are in YouTube, okay.
Yeah.
So we get started with today's session. So can I start presenting my PPTs?
Yes, sir.
So let me, I'm sharing it. Is the PPT visible?
Yes, sir.
Are you able to see the PPTs?
Yes, sir.
Okay. So so I'm sure that for the last 4 to 5 years, 4 to 5 days, this FTP is being conducted on a very recent topic. I mean, it says emerging research trends in computer science and engineering, which really includes most of the emerging areas which is coming up these days, and people are so active working on these areas. Now, I wonder if I can see some of your faces before I start, because I'm just looking at the screen. I don't get the feeling of a classroom environment or in a conference. So may I request some of you just to switch on a video just to have a look, so that I have a feeling, yes, I'm speaking. Otherwise, it becomes quite passive. Because teachers will love to see the faces of the participants.
Sir, namaskar.
हाँ नमस्कार नमस्कार क्या कर रहे हैं?
BS Panda, sir.
Oh, BS Panda. Okay, so nice. So yes, that's really good. That's really good. So we can really start. Because many times, you think as if an intelligent agent is speaking for you, and there are intelligent agents sitting in front of you, and there is no real communication. There is no real communication between the real agents. That's why it's always a good feeling to see the participants, and then it makes sense, because you know that you are speaking to a live audience. So that's the reason why I just wanted to just check. Okay, so we'll get started with the topic for next 1 hour or so, and maybe some questions in between, wherever you feel like, or maybe you can push your questions till the end of the session. Before I begin, I just want to make sure that the PPT is visible to you and my voice is audible. Can one or two respond, because we are so much dependent on the. Okay.
Yes, sir.
Because
yes,
Visible, sir.
okay. Thank you, sir.
Yes, sir, visible.
Thank you so much. Because we are so much dependent on the internet that many times we plan something, and because the internet come to your rescue, doesn't cooperate, and things really go bad. So I'm sure this is not going to happen today, though I can see I have a little poor internet connection, but I'll try to manage. So how wonderful it would have been today that somebody else would have delivered the talk on my behalf. So I'm referring to my secretary or my intelligent agent, who has learned the way I speak, the way I explain things, and in my absence probably do the same thing for a live audience like this. So that is where we begin with the topic called intelligent agents. And I was really wondering, we had wonderful topics for this FDP, starting from sensors, Internet of Things, to cyber physical space, quantum computing, and many more. So today being the last day, probably you are all exhausted. So therefore, I won't give you a lot of mathematics. Of course, though you have a session in the afternoon that will be full of mathematics, full of set theory, full of rough set, and so on. But this session, I will try to make it a little lighter. and I'll try to share some of my ideas, how things are moving and how things will be in days to come. So, as the organizer, Dr. Gantath, has already rightly pointed out that today's topic is intelligent agents, and we are going to talk about autonomous agents. So we'll see what are those things. So I'll just look at the concept of agents, the notion of agents, from slightly a philosophical point of view, because I understand that all of us are aware of the power of artificial intelligence that people are talking about. Now, the word artificial intelligence is not new. It was there for a long time. Those of you who have taught AI in your classes, you might have referred to Aristotle, who said, a day will come when we are going to build systems, which build machines, which can work on behalf of human beings. So that was way back in the BC, before Christ. But today we find it's so relevant, even the politicians that take pleasure in using the word artificial intelligence. Okay, so artificial intelligence is an umbrella term which covers many things. It talks about agents, it talks about machine learning, it talks about data mining and varieties of other things. But today I will focus on what is known as autonomous rational agents. In fact, when I started my PhD work some 25 years back, this was my topic. I developed a formal model for service-oriented software agents. And then people said it's a hype. And though there were research activities going on in different places, but people said it's just a hype, nothing is going to happen. But of course, it took backseat for some time. But today, again, it's quite back, very much back into our research arena, in our research domain. Now, if any of you heard about these agents, the autonomous rational agents, it's quite okay. But for the benefit of those who are coming across this word for the first time, so I'll go in a very systematic way. The idea is not to really give you some solutions right away, but trying to motivate you to do a kind of research or take projects where you can really apply your thought process, where probably you can apply what all that goes on in your mind and try to build system which will probably try to mimic the way the human beings they do things. So let me go with a simple explanation of description of what is an agent. An agent is anything that can be viewed as perceiving its environment through sensors and acting upon the environment through effectors or actuators. So we are trying to look at an agent with the capability of perceiving what is happening around it in its environment. How does it perceive it? With the help of sensors or with the help of other devices or the messages it receives. If it's a software agent running on an internet platform, so it is the messages it receives from a variety of locations. And then it doesn't just perceive, but it also acts after doing some initial processing on the data that it has received from outside. Okay, I find there are some network issues. Let me try to switch off the video so that the sound quality is better. Okay, creating problem. Okay, I'm back. So it's visible? This PPT is visible? Hello? The PPT is visible?
Yes, sir.
Yes,
Visual,
sir.
sir.
Yes, sir.
Yeah.
Visible.
I just switched off the video because the network quality is not good. Okay. So we are looking at an agent as an artifact which has the capability to perceive its environment and then act upon it with the help of actuators, with the help of maybe some mechanical devices or some kind of a software module which does certain things. Now, another important word that is associated with agent is autonomy. Now, what do you mean by autonomy? For example, our institutions, they have autonomous status. What does it mean? It means that may I request people to mute their mics, creating some noise. Please mute your mics. Katar, can you just check whose mic is on so you hello? Hello. Katar, can you just find out somebody's mic is on? Switch off. Okay. So, so the another term that is associated with the agent is the autonomous nature, the autonomy that we are talking about. Now, what do you mean by autonomy? Is the ability of an agent to act without much intervention, without much interference of human beings or maybe any other system. Rather, the agent has learned over a period of time out of his experience, and then it behaves in a particular manner. So that's what we mean by the autonomous nature of the agent, the software agent that you're talking about. Now, you must be thinking that what is this agent? How does it look like? Okay, the agent can be implemented either as a hardware, a pure hardware, or a pure software, or a combination of both. I think Mr. Gantat, just a minute before, he referred to Alexa, right? So where Alexa is a device which takes the input from outside and does it processing, internal processing, depending on how the process has been developed, and then it reacts to that, it responds to that in a particular manner. So agent can assume anything, either in the form of a hardware device, or a small component, or a software, or a combination of both. Now, why do you need this very concept of agents? Why there is a need for agents? Now, if you see over a period of time, the way things have moved, the way the applications have been developed over a period of time, you see that most of the applications are internet based. And people have started talking about web services. So everything is provided in a form of services, whether it's a microservice or a macro service. So you ask for a service in the internet and the service is delivered to you. People have started depending on sensors, which has taken the form of Internet of Things. I think there was a topic, I can see one of the topics for this FDP was Internet of Things. And so much so, people are looking at what is known as cyber physical systems, where the information that you gather from the bottommost level of the pyramid, you gather those, maybe you maintain that in a cloud, and all your physical systems are now monitored from a remote location because you have gathered enough information, maybe through sensors or through different devices or different transactional data that you have gathered. And somebody at a remote location is trying to take a decision and trying to monitor, control the physical systems in the cyberspace. So this has been the trend today, and more applications are any one of this nature. Now, when you talk about these applications, there are a few things that you observe. So there is massive exchange of data, a huge amount of data that is being transferred, transacted over the internet. And people are expecting faster delivery of all kinds of digital services, e-services. We don't have patience to wait. We ask for a service, we want that should be available at our doorstep. And not only that, the applications have become so sensitive, so critical, so delicate that we just cannot afford decision making to happen at a time-taking decision making. We want the decision making has to be very fast and at the same time consistent. Now, probably these are the requirements where we are looking for alternatives which can provide solution to these kind of evolving requirements, looking at the present application scenario. Probably things are going out of the clutch of the human being, because in some situations we may not be able to act as fast as a machine can do that, or we cannot guarantee that our decision making is consistent in all situations, because human beings can get angry, human beings can be very happy. Now, depending on the mood of the person, the decision making is also influenced by that. So this is typical human nature. So if you are looking at software solutions, or if you are looking at some kind of a computer solution to these kind of requirements, we have many things on our mind. We want that these agents that we develop, which we expect that they're supposed to work on our behalf, they must have the ability to interact with different internet data sources. So we have a lot of data sources which are connected to the internet, and all of those are accessible over the internet. We expect that these agents should have capability to process our emails, process our voice, and all kinds of electronic messages that we exchange every day and every now and then. So this is basically a typical characteristics of a secretary which helps the boss, which helps the manager. These agents must have the ability to communicate with other agents. I think towards the end of this talk, I will talk about what is known as a multi-agent system, where these agents are supposed to interact with other agents which are also there in the internet, very much doing their own job. They can accurately represent our needs and preferences in the network information environment. We want our agent to do that. And not only that, they also engage themselves in higher level operations, like agents can negotiate with other agents, agents can collaborate with other agents, or agents can coordinate with other agents to achieve some goal. So it's a typical human nature. For example, if I want to buy something from my college, normally we ask for tenders, and then the person comes probably to our office, and then we get into some kind of a bargain, some kind of a negotiation. So we are envisaging an environment where there won't be any human interaction, but probably I will send my agent, I will deploy my agent in the internet, and all the vendors, those who are interested to provide certain items that I'm interested to buy, they can deploy their own agents in their own web servers. And these agents, they interact among themselves and arrive at a negotiated price with certain terms and conditions. Now, the advantage of doing this is a human being is not necessary to be available to engage in this kind of negotiation, but simultaneously, agents can be cloned. So I can deploy 10 agents which will represent me, and similarly the vendors can deploy many agents, and simultaneously, concurrently, many such negotiations can go on. Just to give a simple example. So I'm looking at a software agent or with any kind of an artifact which is going to act on my behalf for any kind of application where I want to deploy my agent, my secretary. So what is a software agent? So many times it comes to our mind, what is a software agent? People have tried to define it in different ways depending on the application for which they were developing the software. So therefore, there is no commonly agreed definition for that, but all of them, they have certain characteristics in their mind. They expect that the agent must have certain typical base characteristics. What are those? Essentially, the agents are meant to act on behalf of a human being. That's the first thing. These agents must have the social capability, in the sense that they should have the ability to interact with each other, with other agents, other systems, even with human beings. The agents must have the decision-making ability so that it can take decisions on my behalf, on the behalf of the human being who is deployed there. And it has the capability to adapt to changing environment and also learn when the interaction is going on. It's learning things from the interactions. And the last characteristics, which may not be necessary always, but for some applications you may need it, what is known as a mobile agent, where the agent can really move from one server to another server in the internet, talk at a particular server, does some processing, and then move. For example, a web crawler. A web crawler is nothing but a mobile agent. I need certain information, and it moves from server to server, does the processing at the local server, and keeps informing me, keeps sending me the required information, which is of some use to me. So this is what is known as a mobile agent. But anyway, mobile agent may not be necessary for all kinds of application, but for some application, you may deploy the mobile agents. So that is briefly what exactly the basic characteristics that you are looking at in a software agent. But of course, there are some definitions which are widely accepted because these persons are some pioneers, those who have worked in this area quite for a long time. At least for the last 30 years, I have been reading their papers. Udrich and Jennings, they define the intelligent agent as one that is capable of flexible, autonomous action to meet its design objectives. So there are two things which you can see in this definition. The one is each agent has a design objective. It has a goal to achieve. So for example, you can those of you who have been teaching AIs, you know that AI systems cannot be built to solve varieties of problems. They are domain specific. Therefore, here also, the agent must have a specific design objective. For example, an agent is designed to filter emails, so it should do that. An agent which is supposed to do some kind of monitoring of a patient at a remote location, so it is designed for that. Now, while doing that, it must enjoy flexible behavior depending on the situation, because the situation may change in the environment. The situation may change depending on the kind of events the agent is going to handle, and therefore it must exhibit flexible behavior. Now there are three typical characteristics. The first two are very important, and the third one is basically you need when you are operating in a multi-agent environment. Now there are two types of agents. We can separate them as two different types of agents, or we can have a hybridization of both the characteristics built into the same agent. The first one is reactivity. Many times we call it a reactive agent. What is the nature of a reactive agent? It responds. It responds to the signals, the events that happen in the environment in which the agent is situated. So it is trying to achieve its goal, and at the same time it is reacting. It is responding to anything that is happening in its environment. I think these kind of agents are very much pertinent in an industrial environment or in an environment where human beings cannot probably go and they are deployed to do certain things. Just imagine an agent which is deployed in the surface of the moon or in a war zone where it is gathering signals through radars or through other devices and acting in an appropriate manner. Now there is another kind of agent which is known as proactive agents. Proactive in the sense they have a definite goal and always they are trying to achieve their goal. So many times we call this a goal-directed behavior. So they are deployed for a particular purpose and they can do that job very well. Now these kind of agents, if it is only a proactive agent, many times the agent will not have the capability to respond to changing scenarios. So it is always assumed that this agent will operate in a very ideal environment and therefore it is able to achieve the goal. For example, you have designed a robot which is supposed to move to a particular room, pick up a particular object or pick up a particular instrument and come back. So it knows how to move through the terrain or through a particular path, plan out its movement to reach to the object in a minimum time and get the job back. But in case something happens on the way, suppose that an obstacle comes on the way, probably the agent will not be able to respond to that because maybe it's not designed for that. Therefore, only a reactive agent or only a proactive agent may not be sufficient, and most of the time a real agent should have both the properties like human beings. As human beings, we have our goals to achieve. I know what I'm trying to do. At the same time, when things change in my environment, I know how to respond to that. So you want to have these kind of attributes in a software agent or in a hardware agent or an agent which combines both. Now the third one is basically the social ability. I think some months back I referred to that. So this is necessary because as human beings, we may not be able to achieve everything of our own. We cannot live as independent entities. We need to cooperate, we need to coordinate, we need to negotiate. So there will be occasions where you have to interact with other agents. So this is the ability that is required of an agent which can really interact with others. Now what you need, what exactly you need to have this kind of ability? It should be, the ability should be the ability to communicate. So you need to define the appropriate communication structures, interaction structures, the communication primitives using which these agents can communicate among themselves. Now, of course, I'm not dragging you to natural language processing because that's a different area, but one can define some speech acts or action primitives, sorry, communication primitives using which you can just express your intent. So maybe towards the end, I'll discuss about that. Okay. Now this is what we have been discussing till now. So typically it looks like this. So if you around the dotted line, if you think that that is what the agent contains, you can see there are a few things. We have mechanism through which it can receive the observations, it can receive the percepts, and there is an agent function which does the necessary processing, and then there is an actuator. That there is an actuator which helps you to take an action, bringing changes in the environment. So that's what the definition says, right? An agent is a hardware or software component that is situated in some environment and is capable of autonomous action in order to meet its design objectives. And the typical characteristics are responsive, it senses changes in the environment and acts, it is autonomous, it has control over its own behavior, its own state, it is goal driven, it's not just occurring just like that, but it has some goals to achieve. It works continuously in the environment, gathering data from its environment and responding to them, and of course interacting with the other agents. Now I was just imagining a high level model where you find the agents and the IoT together. I think those of you are working in Internet of Things or sensors, you know that you have sensors which are deployed, which can be deployed in strategic locations for varieties of applications and gather data. Now what do you do with that data? Right? What do you do with the data? You do decision making, you do analysis, you prescribe certain things, you gather a lot of statistical information from that, you trigger actions based on what the sensors they really give you. So there's a whole lot of things that is going on in the sensor level, and that is how it's not that the sensors just gather information, but they also pump the data into the internet so that it can be sent to a remote location where the decision making is done, and the devices are controlled and some actions are initiated. Now, when these sensors they gather the data in a remote location, all the data that the sensor gathers need not be transferred to the server for processing, right? Maybe you need a little bit of filtering because the sensor is open 24 hours and it's continuously gathering information, but you don't have to capture each and every bit of the data and send it to a remote location to process it, because if you do that, there will be heavy congestion in the network because the number of sensors are growing so fast that if every sensor will start sending data over internet to a remote location, I think we will not be able to use even WhatsApp because the net will be so much congested with this. So you need some kind of decision making ability even at the root level, even at the sensor level, which will take a decision which data to capture, which data to send, which data to drop without sending. So I can envision that probably you need kind of a software which will sit inside these sensor devices and can do this job. Whether the sensor is deployed in an agricultural field or if the sensor is deployed in a theater which is trying to monitor maybe the temperature, the pressure, the light, and so on and so forth. I think you had a session on this. You might have come across very interesting applications. Just imagine each and every those applications that we discussed. Now you can see there are a lot of unnecessary data, a lot of noise that is gathered through through the sensors. But you need some kind of filtering mechanism so that you only filter out that data which may be necessary for you to take decisions. So I can find the agents deployed in those sensors which can do this kind of data. It's not only that, there are need for high-level processing where you can have a set of agents, a layer of agents which can learn from what is happening in the internet, and they build models, classification models, clustering models, rule learning models, and these models can be stored in the state of the agents, which can be later used for predicting, for decision making, or for any kind of analytical operation. So this high-level agent-based IoT model is a scenario which I can immediately see where it necessitates the design of agents which can do a lot of things on behalf of a human expert or a human being. I can also see another application. I think all of you are aware of the web services, right? So this is just a model of a cloud service model where the cloud provides different types of services. So whether it's a software as a service or infrastructure as a service, or platform as a service, security as a service, so anything is now viewed as a service. Now these services are provisioned to the user who is requesting for a service in a continuous manner. And when I ask for a particular service, maybe I don't have patience to wait. I want my request to be processed as quickly as possible, and I should be given the service. Now, of course, when I get a service, I need to pay for that. There is some kind of accounting mechanism which has to go on the background so that it does the pricing. Now, from the provider point of view, it has to do a lot of resource allocation, allocation of the virtual machines, sometimes transferring one process from one virtual machine to another virtual machine, because I don't want to keep the virtual machines always live, because I have to pay for that. It consumes a lot of power. So I do some kind of allocation of the virtual machine so that I make the optimum use of the resources which is available to me. I mean, I'm talking from the service provider, the cloud provider point of view. And of course, there are also issues like service level agreements. It's an agreement between the provider, the service provider, and the requester, like we. I'm asking for some memory locations. I'm asking for some bandwidth for a particular period. Now, for example, the FDP is going on online, and maybe I have paid a little more to get better internet service. So the provider has given me enough bandwidth for a duration of 1 hour or so that everything goes very smoothly. Now, when you have this kind of, when you get into this kind of a contract or this kind of a service level agreement, somebody has to monitor whether the services are delivered as requested, whether the quality of service is maintained as requested. Otherwise, there can be a penalty from both sides. So I just give you some scenario. It can really go on. I can give you some scenario where you need some automated operations to happen, which can monitor things when it's going on the fly, and then does this kind of allocation of virtual machines, monitoring whether the quality of services are provided as promised or not, doing the pricing and everything. And here is again a scenario where I can see the deployment of software agents in different strategic locations to do things in a consistent manner and raising alerts whenever it is necessary for somebody to respond in the most appropriate way. So immediately I can see these two applications, because these are the two applications which I have been working on. There will be many where you can really find the potential use of agents. Now the next question is, fine, the concept of agent is fine, but how do I realize that? For example, when people talked about object-oriented programming, there we really struggle very hard to understand what is a class, what is an object, what is a behavior, and so on. It went on for some time because it remained as a concept in the initial stages, in the design stages. But later on, people realized how to program an object. Now, exactly in the same line, Shoham, who did some pioneering work, on agent-oriented programming. He came up with a new programming paradigm known as agent-oriented programming, which had some societal view, societal views of computation in the programming. And the first version of agent programming was Agent Zero. So that was a programming platform which Soham proposed to do a bit of a simple agent-oriented programming. Now, these programming agents was designed in terms of some mentalistic notions. Now, what are these mentalistic notions? These are notions which are commonly found in the behavior of human being. If you try to explain the behavior of a human being, I look for artifacts, I look for concepts. For example, how a program can capture data. Let's talk about object-oriented programming. So you can capture the data in the form of data members. How the class can exhibit behavior, it can be in terms of member functions. So you have artifacts which are required to explain how to store the data, how to exhibit a particular behavior, and so on and so forth. Exactly in the same way, for agent-oriented programming, he came up with some mentalistic notions, some humanistic notions, which he found to be very useful to explain the behavior of human beings. So he used three terms like belief, desire, and intention. It looks quite funny because these are the terms which normally we associate with human beings. Human beings, they believe certain things. Human beings, they have desire to achieve certain things, certain goals. And whenever an opportunity is given, they have the intention to immediately implement all those intentions through a well-drawn set of planned actions. So these are normally the attributes of human beings. So he started designing this programming language with these humanistic attributes like belief, desire, intention. But initially when he did that, and of course he could build small applications with the help of these three ideas, people laughed at it. They said, okay, these are not for programming. But later on, it so happened that many of the applications on agent-oriented approaches, that use agent-oriented approaches, they use these three artifacts. Of course, they have added a few over a period of time, but these are the three basic ingredients for building any agent-based system. I'll just expand a little bit. So, can somebody respond? Is that okay? Am I audible till now? Things are going fine?
Yes, verify.
Because it looks like I'm just talking to the screen.
No,
So that
no.
so that is the problem when it's a virtual event. Anyway,
No,
so
sir. Very interesting.
Okay, right. Okay. So Gatat, if the network connectivity is giving some problem, you can send me immediately in WhatsApp message, because my WhatsApp is open. Because I'm not able to know like whether things are going or disconnected and so on. So if you find some problem, send me a WhatsApp message. Contact, right? And this gentleman, Michael Bratman, he gave the theory of human reasoning, again with the help of those three artifacts: belief, desire, intentions, which are viewed as the mental states of a human being and souls the mental states of a BDI agent. Now, as I've already explained, that agent takes input from the environment and builds a mental model. Now, how does it build a mental model? The mental model is nothing but the set of beliefs, the set of desires, and the set of intentions. Now, the action of it is believed, and the design is done in such a way that the action is triggered by the set of beliefs, the set of desires, and the intentions which the agent carry. Now, very quickly to give you, just to motivate, just that I'm not just telling you a story, I'm not just telling a theory. There are huge volume of research papers which are available on this area. You just search BDI agents, you will find a lot of things in that. Very recently, I was attending a conference. The IIIT Bangalore. There's a group working there. They are building an agent-based system to monitor air traffic using the BDI concept. And then I was interacting how they have developed and all that. It's a very interesting thing. So they want to deploy an agent which will monitor the flights landing and flights taking off Now that will be done through an agent which is deployed in a server, and the function of the agent is built on this paradigm, belief, desire, intention paradigm. And then of course they have taken ideas from the airport in Sydney, where also they are using these kind of agent softwares which are deployed on their air traffic control offices, which does this kind of landing, because those are huge airports, and there is a possibility that there can be human errors, and we know if there is a human error, what happens to the flights when they are landing or taking off. There are a lot of disaster that is happening. We get to hear about those disasters, and most of the time it is a human error. Now to avoid those kind of human errors, they have, over a period of time, they have developed agents which are doing the job on behalf of the human being. Of course the human being will be there, but most of the things will be done by the software, automated software which are running on those ATC control machines. Okay, so that's a typical picture, that the BDI agent has beliefs. The beliefs are nothing but the input it gathers, the data it gathers from its environment, and the way it has been developed, the knowledge base, let's say, to make it simple. And then it has some goal to achieve, the desires, and then the intentions. Depending on the current situation, it decides, okay, what are the desires that can be implemented, and then it draws out plans, and finally it tries to execute the plans. So that's a very simplified. It's not as simple as I'm saying, but I'm just trying to give you a very simplified idea of how the BDI, what is the control structure of a BDI agent. Now, just to give you a little more information about what exactly the beliefs, desires, and intentions they actually mean. Like I said, in object-oriented programming, the data members are the ones which will capture the values, and the member functions are the ones which will exhibit behavior. So exactly in the same line, beliefs represent the characteristics of the environment. What the agent sees in the environment. For example, the agent is deployed in the ATC, air traffic control device or machine. It knows about the runways. How many runways are there? What is the length of the runway? Which runway should be used for what kind of flight? If it's a Boeing, which runway should be used? If it's a smaller one, which can be used? And what is the timing? Where it should immediately take off? There are different markings on the runway, where the information should be given so that it starts taking off. Where it should land? Where is the taxi? In the sense that where these flights are going to come to the the flights will be docked in a particular area. So these are the environmental information which the agent carries. I'm just using that as a running example, the air traffic control agent as a running example. Now, and these beliefs are not static. Once I have a belief, it doesn't mean that it will remain same for all time to come, but it'll keep on updating, because every time I find there is a change in my environment, and I have to act in a proactive manner, in a responsive manner. I'm not passive, but I'm observing what is happening. Therefore, the belief is updated. The belief set is updated over a period of time. So, in a sense, the beliefs can be viewed in of the system. If I try to give a human example, each human being has information, right? So when I'm doing something, I have certain information in mind. So based on the information that I possess, I perform actions. So this is the capability that is given to the agent, which you call as the informative component of the agent, which basically serves the base, which serves the basic things on which the agent is developed. Now the second one I said, the desires. Now these desires basically they contain the information about the objectives, the goals to be achieved, and the priorities, and sometimes the payoffs, in the sense that if I achieve this, how much I have to spend. If I achieve that, if I have another alternative, how much I have to pay. Some kind of a cost-benefit analysis that it also carries. Now this can be thought as the motivational state of the system. So I behave in a particular manner depending on what is the state in which I am now. So it is the motivation that drives me to act in a particular manner as human beings. So I would like to see the same thing in an intelligent agent which will work on my behalf. And the third one is the intentions, which represent the currently chosen course of action. because I may have a lot of desires, but right now, depending on the context, depending on the situation, I'm taking a particular decision, and that is transformed. My desire is now transformed into an intention. Now this captures the deliberative component of the system. So I talked about. So just to give an idea, what does this intention mean? So let's go back to the air traffic example. Now the air traffic agent has information. Let us say there are 4 runways, and the first runway is used for international flights. The second runway is, let's say, used for the domestic flights. The third one is for the military if there is some kind of emergency that is used, and maybe another one for another purpose. Now normally that's how the runways are used. But in a given situation, on a given particular day, when there is thunderstorm, there is raining and all that, suddenly I find there is a smaller flight and it has to go for emergency landing. Now even if the runway that is designed for that particular flight, because a domestic flight has to take a particular runway, but because of the emergency, because of the situation in which that operation has to be carried out, maybe as a human being, probably the controller would allow the flight to land in a runway which is meant for a international flight, let's say. So that is, depending on the current situation, you are slightly deviating from the normal course of action, but you are trying to achieve it in a different way. So that provides the what you call the deliberative component of the system. So typically an agent will have these 3 components: the informative component, the motivational component, and the deliberative component. Now these are the guiding force of for an agent to be agile and to perform in a particular manner. So some typical figures. The agent is guided by some beliefs and desires. Now there is a selection function, because the selection function will tell me what I should do at the present situation, and that becomes my intention, and I try to achieve it by using whatever option that is given to me. Now if I try to formally model an agent in a very high level scenario, because ultimately we have to write programs, we have to identify the variables, we must have a mechanism to store that. We need to write many functions, because these are the functions which are going to implement my ideas. So a formal model of a very simple agent would look like this. So the environment has many states, right? Because the environment will change from stage 1 to state 2 to state 3 to and so on. It continuously changes. Now my agent is observing things. So maybe the C function. So I'm just writing the first function is a C function. The C function is basically it's observing my environment, and I'm gathering information which I'm going to capture and keep it as my belief base built into the agent. So this function is basically receiving the senses, the signals from the environment, and trying to build the belief base over a period of time. The second function can be the next function, where an agent has an internal state, IS, the internal state, and which is being updated over a period of time. So every time it receives a percept, it updates its internal state, right? Just now I said normally a particular runway should have been used for a particular type of flight, but depending on the current situation, so now my percept has changed, my internal state has changed. Then there is an action function which will enable the agent to choose a particular action from many alternatives. So you may have alternatives like A1, A2, n number of different actions, alternatives that you may have, but you need to choose a particular one in a given situation depending on your internal state. Now once you act, you are also bringing a change in the environment. So the effect of an agent action is also captured through a function called do. Do is a function which will try to implement the action, and then in a given scenario which is characterized by a set of states. Now when you perform an action, now there is a change in the state. That's how, if you take these two as inputs, the action and the state, now this is bringing about a change in the state. Now slightly in a programmatic style, maybe you can just write a simple code that how this the formal notation